So imagine now that we have A for brown eyes and recessive A for blue eyes. And the exercise tells us that 11% of our population have blue eyes. Now, can we use the Hardy Weinberg equation to calculate the allelic frequency of the dominant A and the recessive A by using just this information? The answer is yes. So, as I said, in Hardy Weinberg, you always symbolize the dominant with the P and the recessive with the Q letter. Also, we remember about the equations that we have and what they represent. So P squared plus 2PQ plus Q squared equals to 1, and also that P plus Q equals also to 1. This P squared represents the homozygous dominant. The 2PQ represents the heterozygous people, and the Q squared represents the homozygous recessive people. So let's go back to our information. 11% have blue eyes. Who has blue eyes? The people that have this genotype. So this genotype can be represented by Q squared. So we can say that Q squared is equal to 11. Or I can write this in decimals, like Q squared equals to 0.11. Now I can square root that to find the number of Q, which is 0.33. Since I managed to find the Q, then I can use this equation to also find the P. So P plus Q equals to 1. So P is equals to 1 minus Q. So P is equal to 1 minus 0.33. So this is equal to 0.67. Therefore, what do I have here now? I know that the Q equals to 0.33 and the P is equal to 0.67. So this is the answer for the question, but I can also find more things if I want to. For example, I can find how many people have the homozygous dominant genotype, since I know the value of P, and I can also use this, the 2PQ, to find how many people are heterozygous.